In this video, we're going to continue our work in solving systems of linear equations by using substitution or elimination addition method with some examples that feature coefficients that are fractions. So take a look at our first example here, and you can see that we've got all of these coefficients that are fractions. So in order to solve this system, we are first going to clear the fractions. So what that means is that we are going to multiply both sides of each equation by a number that will then get rid of the denominators. So let's take a look at that first equation, which I'm rewriting here. And if you see that we have a denominator of 3 and we also have a denominator of 5. So we will be using the least common multiple to clear the fraction. Now the least common multiple is the same as the least common denominator. In other words, it's the smallest number that 3 and 5 are both factors of. And in this case, that number is 15. So in this particular first equation, we're going to multiply everything, both sides of the equation, by a 15 over 1. So that's what I'm doing here. Notice how I'm going to write my 15 over 1 on both sides of the equation. And you want to watch for that, because I will sometimes see my students, they'll multiply the left side of the equation by the least common multiple, but they'll forget the right side. Okay, so both sides. Now we are going to distribute here on the left-hand side. I'm going to write down the middle steps so that you can see how I've distributed that 15, okay? Especially that second term here with the 1/5 y, because sometimes students miss that. And so here is our rewritten first equation with that least common multiple throughout. Why I did that is, notice how now I can go in and reduce here. So 3 goes into itself once and into 15 5 times. So when I multiply these first two terms here, 5 times the 1x, I get 5x. And notice there's no fraction, all right? That's the whole purpose. Okay, so here we go. 5 goes into itself once and into 15 3 times. So then now we have negative 3y as our second term. And again, our fractions are gone. And then finally on the right-hand side, 5 goes into itself once and into 15 3 times. And 3 times 12 is 36. So our first equation has been transformed to this much easier to handle equation. Okay, let's do that same procedure with the second equation, and you may have noticed that the second equation is a tad bit easier, isn't it, to find that least common multiple, because all of the denominators in that second equation are 3. So we are going to multiply both sides of this equation by 3 over 1, and that's going to clear our fractions. So again, we will be doing a distributive property here, and we have 3 over 1 times negative 1/3. Well, let's write that down. Easier to watch, to follow that logic, right? So 3 over 1, notice how I write it 3 times, because every term gets that 3 over 1. Okay, so now again, 3 reduces 1 times 1. So here I have a negative 1x, and then again here we will reduce, plus y equals, and then here we reduce the 3's and we get a negative 10. So that's equation number 2. So number 2 and number 1. So let's rewrite this system now that we have here, because now we have some work to do, don't we? Okay. So I went ahead and rewrote the system now as it is, and we get to choose which method we want to use. This is a personal choice at this point, right? We could choose either the substitution or the elimination method. I think I'm going to go with the elimination method here, because I've got some coefficients in the x, for example, where I have a positive 5x here and a negative x in that second. Be easy for me to turn that negative x to a negative 5x, wouldn't it? So I'm going to multiply the bottom equation by a 5. Okay, I'm going to rewrite the top equation here, because we're not changing that one. And then I'm going to distribute that 5 all 3 terms. So that gives me negative 5x plus 5y equals negative 50. And now we're going to add, and when we add the two equations down, as you know, the x's give us 0, right? And that's why we chose that 5, because we wanted a 0x here. And then for the y's, we get 2y, and then a negative 50 added to a 36 is a negative 14. And now we're going to divide by 2, and so my y equals negative 7. Okay, so now I get to choose which equation I want to substitute y equals negative 7 into to solve for x, I'm going to use that bottom equation. So negative x plus negative 7. See how I substituted in negative 7 for y? Equals negative 10. And then I'll go ahead here and add 7 to both sides. So negative x equals negative 3, and then divide by negative 1. And we're getting x equals 3. And so we are getting that our solution is 3, negative 7. Now, if you want to check this solution back into the equations, I recommend that you go back to those ugly equations with the fractions, because if we made any kind of an error changing or clearing those fractions, then we will catch it when we check. So this is where your calculator might be really helpful to help you check. And so I'm going to start with that bottom check. And so I have negative 3, I have negative 1/3 times x, x is 3 over 1, plus 1/3 times y, which is negative 7 over 1, and we're checking to see if we get a negative 10/3. And I'm going to multiply across. I'm actually not going to reduce those because I want to keep the common denominator. And so notice that this really does check in the bottom equation. And now we're going to check in the top equation. And again, I have 1/3 times 3 over 1 minus 1/5 times negative 7 over 1 equals 12/5. So that's what we're checking. This time around, I am going to reduce these two 3's. I want to be able to use 5 as my denominator instead of 15. So I'm being kind of clever here. And so I have 1, and then here plus 7 over 5. And you know, 1 is 5/5. So 5/5 plus 7 over 5, that does equal 12/5. So we have checked our answer. And I won't be checking all the answers in our video necessarily, but I wanted to show you that first one. So again, 3 negative 7 is the solution to our system. And if you're classifying your system in your class, that would be a consistent system with independent lines, and we have found where the two lines cross. Awesome. Let's go to the next example. Okay, so here's example 2. We're once again going to be multiplying to clear the fractions, and in that top equation, I think you'll agree that 4 is our least common multiple. I'm going to go ahead and multiply by 4 over 1, both sides of the equation. Now again, even though the right hand side is a whole number, right, or an integer, right, no fraction, you do have to multiply that least common multiple times both sides of the equation. That's really important. Let me distribute here on the left hand side, and I'm writing this middle step to help you, where I multiply that 4 over 1 times every single term there, and we get a negative 8 here. So then I'm going to go ahead and reduce here and here as well. So here I get negative 6x minus 5y equals negative 8. So this is my new equations, negative 6x minus 5y equals negative 8. Okay, we're going to clear the second equation, and there you can see that the 20 is going to be our least common denominator. So we're going to multiply by 20 over 1 so that we can clear those fractions. And I'm going to distribute everywhere, including this side. Let me see, let's do this. Okay, just like that. Okay, 20 over 1 times 1/2 x minus 20 over 1 times 2/5 y equals negative 3. I'm going to go ahead and reduce those here. Equals negative 3. We have 2 goes into itself once and into 20 10 times. So we get 10x. I'm going to write it up here. 10x. And then here 5 goes into itself once and into 24 times. And I have a negative 8y. And that equals negative 3. Okay, so this is our new system. And I think looking at all those coefficients, that we should use addition method once again, or elimination method. And we are going to, let's eliminate the x's, since those are the terms that are opposites, exact opposites. All right, so I'm going to multiply the top equation by a 10. Nope, I'm not. I'm gonna actually go with a smaller number. I'm gonna multiply the top equation by 5 because I can change these coefficients to 30. Can you see that? I could use 60, but 60 would be big. I like to keep my numbers small. All right, so that's what I'm going to do. And so then here I have negative 30. Well, I'm going to come down here next. negative 30x minus 25y equals negative 40. And then I'm going to distribute the 3 in the second equation, and I get a 30x minus 24y equals negative 9. And then I'm going to go ahead and add these. My x's are going to give me 0. I did that on purpose, right? And then over here I have negative 49y equals negative 49. Well, isn't that handy? Y equals 1. Ah, I love that. Okay, and then I get to choose. So I'm going to go with my top equation, negative 6x minus 5 times 1 equals negative 8. So negative 6x minus 5 equals negative 8. Add 5. So I get negative 6x equals negative 3 and negative 3. And when I divide by the negative 6, does look like I'm getting x equals 1/2. My solution is 1/2 1. And I'm going to leave the check to you. So for this last problem, I want you to pause the video and give this a shot. I want you to try to clear the fractions first. Now, I am going to help you just verify for you what numbers you should be using. So in the top equation, let's clear the fractions by using the 10. And in the bottom equation, let's clear the fractions by using the 15. Okay, so now pause the video and do the rest of the problem, and then when you unpause, you're going to see my answer and we will compare. Okay, pause now. Okay, so when I cleared the fractions, I ended up with 4x plus 6y equals 11 and negative 6x minus 10y equals negative 17. And then I used elimination method again, just by coincidence, and I got rid of the x's, so I multiplied by 3 and 2 to get 12s here. I added together to get y equals 1/2, and then I substituted into the top equation to get x equals 2. So 2 1/2 is the solution. I hope this has helped, and I hope you did well. Okay,